When should we do it? Now. Right? P-value's low. P-value's low. How do we solve this problem in the court case? What's the significance level in a court case? You know this. Not a number. What? Isn't it when we say beyond a reasonable doubt, aren't we talking about a significance level now? Right, the reasonable doubt is beyond which we're going to reject. We're going to say, if the null is true, there's little chance of seeing these results. Does that make some sense? Okay? All right, look at the study guide Kevin just gave you. Elaine, I'll put this on Edline.
It's Esther.
Esther, I'll put this on Edline. Okay? So, here's the vocabulary, type 1, type 2. I cross that p-value as the probability of making a type 1 error out. I don't like that at all. Just cross that out. I think that confuses them, so I'm taking that off. I'll take it off when I put it online. When you set alpha, you set the highest level of type 1 error you're willing to tolerate. That's the key idea. Now, alpha and beta are trade-offs. So if I want to reduce beta, what can I do? Increase alpha. But that's not right, because I've already set alpha at the most I'm willing to tolerate, right? Is there any alternative for reducing beta without increasing alpha? Yeah.
Increasing sample size.
Right. And what I have to show you when we go back to this and do the calculations is that sample size, this is all a question of sample size. And if you want to have high power, what you need to do is have high sample size. Because one of the problems in like the AP Stat curriculum, because they don't do any of this calculation, they just do what we've done today, like know the vocabulary, is that how big does n need to be in what we've talked about so far? What's the only time we've talked about how big n needs to be? What? Say it louder. NP and NQ bigger than 10, right? And that was to what? To assume a normal. That's true. However, n needs to be way bigger than this in order to have any decent amount of power. And when we go back to calculate this, I'm going to show you this. Okay? Is that our issue with how big n is not this. This is really just very minimal, right? Agreed? Okay? You need large n if you want to detect that a null is actually false. We're going to return to the calculations a little bit. Okay? So read that last paragraph now. And this is the moral of the story, and then I'm going to go show you a two proportions test. Does this make sense? The questions they ask on AP exam are like, give a situation and describe what a type 1 and type 2 error would mean in that context. Talk about what the consequences of them are, kind of like what I was just doing up here with the water. And then pick significance levels based on that. Okay? They do not ask you to calculate beta, but I want you to be able to calculate beta. We're going to return to it. Yeah? All right, so that's chapter 21. There are a couple other things in chapter 21 that you need to read about tonight. Chapter 21 is about like things you need to think about when you do this process of hypothesis testing. Okay? Yeah? All right, let's do something else. This is more straightforward. Look at this problem.
Sorry.
What? Oh.
Oh
My God.
Gastric freezing. So you would swallow a balloon, and then they would pour like icy liquid into the balloon, which would fill up in your stomach, and it was supposed to reduce ulcer pain. Sounds gross. Okay? And according to this, it was widely used for years. So now we're going to do an experiment, and we're going to compare the outcome of gastric freezing with that of a placebo. And basically, you just need to write down the numbers at the last part. The rest of it. Is this a question about proportions or about means? Proportions. Do you suppose we could write a problem about this in terms of means? What would, instead of just saying pain or not pain, what would we do? I mean, improved or not improved, we would do what? Right, we would ask them to rate their pain or something like that. And then that would be a question about means, which we're going to do next class. Okay, but this is proportions. So we've already done proportions, right? Chapters 19 and 20, yes? Yes?
Yes.
Okay, so can we just do this, or is this a different problem? Is there something different about this than the problems that you just did in chapter 20? There's what? Right. Do you hear what he just said? We don't have a number to test. Right? Like when we're doing a one proportion test here, we're testing 1p against some number, 25% in this case, right? But here, how many samples do we have? How many samples? 2. So we have variability in the 1p, but we also are comparing it to something else that's variable, right? Which means we need a different test. This is called a 2-proportion z-test. Are you ready to do it? 90% of this you should already know how to do without being taught. If you get this stuff. If you don't, this is Greek. Actually, it's literal. Okay? Let's do this. Null hypothesis. What should it be? Remember, we got to write it about p's, about parameters, and it has to have an equal sign in it. So what is it going to be? P what? Say louder. I disagree with that. Okay, but this is the way sometimes people think about this first. Okay? So P of the experimental group equals 30 out of 78, which was the number from the control group. Why is that not right? I think you really want to see this. Yes? Right. Do you see that? If you do it this way, you're ignoring the variability of the control group, of the people who get put into the control group. This is sort of the big, I'm glad she said this. This is the big focus of the test, why this is different than the other tests. So instead of P being that, what do I need to write then? Right. So P of the, let's say, experimental group equals P of the control group. And what's my alternative here? What's my alternative? Right, that it would be, well wait, we're measuring whether they improved, right? So what am I interested in? Whether the experimental produces more people being improved, right? Yes?
Yep.
Uh-huh. Agreed? Okay. Now, what is your statistics? What should I calculate? P what? What should I calculate? What's the results of my survey here? Can somebody give me the right notation for those numbers there? P hat. So P hat of the experimental is what? 20 out of what?
20 out of 82.
Which is what? 0.341. And P hat of the control?
30 out of 78.
30 out of what?
78.
Which is? Wait, hold on. Are those right? So the experimental actually did worse? I must have typed this in wrong.
Oh.
I think I typed this in backwards. Let's fix this. $30 of the 78, and what was the other one?
82.
Out of
82.
82. Because it would be dumb to do it in the other way, yes?
Yeah.
Good.
Yeah.
Alright, so let me change those. Right. So, so this is P hat of the control and P hat of the experimental. Okay. And so the people in the experimental got better, right? More improved. So are we done? Are we done?
No.
No, why not? Variability. Okay, but it's not sampling variability. Where's the variability in this problem? We're not taking a sample. Where did the variability come in an experiment? What? Right, in the randomization of the treatment, right? That's the variability that we're now talking about. You have to change your thinking a little bit if you're talking about an experiment. It's also going to change the way we talk about assumptions. So let's do assumptions now. Guess how many there are? 3. Okay? The first one is about bias, but bias isn't the right word here because this is an experiment. Right? It's randomization. Okay? So this is either random samples, but it needs to be 2 random samples now, right? If you're doing sampling, but we're not doing sampling in this particular one. So 2 random samples or random what? Assignment of treatments. You don't want to use the word bias unless it's a problem where you're sampling. It might be a problem you're sampling, right? I might have taken a sample of men and a sample of women and asked them some question, in which case then you need 2 random samples. Okay? What's the second one about? Okay? Well, there's 2 kinds of independence now. Okay? There's independence within groups and independence between groups. You need both of those 2 things. Right? There can't be any interaction. One can't affect the other. But also these random samples need to be independent of each other. Right? That's a different issue than the independent